found, was this a solution or was this not a solution? Franco?
It was a solution because if you just plug in the 8 for y on both and the 1 for x on both, they equal up.
Yes. Many of you did it the exact same way. Who else thought that same thought process or to do it that way? Great minds think alike. There were 2 other ways you could have figured this out. One used our substitution method from last class because these both have a y equals. Set these 2 equations equal to each other, solve, and see if we get the same thing. That'd probably be more to do than this. Or you could have also graphed both of these in your calculator, found the intersection, and then saw that that intersection was the same. So any of those methods would have worked. Trying to exit, but I can't. There we go. Alright, so today we're going to talk about the last way to solve systems algebraically using our elimination method. So everyone should have these notes in front of them. And I'm going to have you guys fill this out. The words at the top are a little small, so I'm going to read those. For our elimination method, Eva, go ahead. We need to add or subtract or multiply and then add or subtract to eliminate a variable. Then, or that's like the method in general, our steps are make sure our equations are lined up, add or subtract the equations together to eliminate the variable that has common coefficients or the number before the variable. You'll get the answer for one of the variables, and then we're going to take that answer, I skipped one, solve the equation for the remaining variable, which is basically what I just said. You'll get an answer, and then we're going to take that answer, substitute it into one of the other equations, and solve for the other variable. So step 3 and step 4 are very similar to the substitution process, but step 1 and step 2 are not. If we don't have common coefficients, that's where this note takes place, then we have to multiply one or both of the equations to make them common. So we'll see what that means here in a moment. Anyone still writing? See some pencils still writing. So let's do some examples. See, let me go back to that. So we're going to start with example 1, so you can go on to the next page. If you didn't already, some of you flipped twice, sorry. So the first step, always look and see, are your equations lined up? So what does that mean is, are your y's on top of each other? Is the equals on top of each other? Are the x's on top of each other? Is the constant on top of each other? If the answer to all of that is yes, then these are lined up, and that box is checked. You don't have to do anything. And then move on to step 2. Look for the variable between your x's and y's on both, and see which one has a common coefficient, which one has the same number in front of the variable. Which one would that be? Does the x have the same number in front of the variable? So then y. It's not shown, but there's a 1 there. That's why they're the same. So because it has the same common coefficient, then you need to ask yourself, what operation could I do to cancel these out? Not divide, right? Subtract. So division in this case would kind of do that, but we want it to completely disappear. Make it 0, but subtract, yes. So we're going to subtract the entire equations from each other. So y minus y would give us 0. 3x minus x would give us 2x. 4 minus a negative 2, be careful with your negatives, it's really going to be a plus. 6. Double check your math in your calculator, especially when we end up with a lot of minus minus. Questions so far? Okay. Then we're going to solve for x. How would we do that?
Minus 6 on both sides.
And then divide everything by 2. So that is part of our answer, our x. We still need to find our y. So I don't know if that's step 3 or step 4 at this point. But we would take that answer and put it back into either of these equations. Does not matter which one. As long as you do the math, they should both turn out the right way. So let's say I choose the second one, just because. And we solve for y. What would y become? Negative 5. And then just as before, we would write our final answer as an ordered pair, x then y, in parentheses. Box in that answer so I know that is your final answer. You are done. Do you have any questions about that process? Have we got that answer? Anything like that? We're going to do the same thing for 2, but it's going to be a little different because the equation is set up differently. That's fine. As long as everything lines up, we don't need to change how the equation looks. So of our 2 variables, which one has the common coefficient? X. They both have a coefficient of 1. So then again, what operation would I do to these to make them cancel each other out? Subtract again. These are good questions to ask yourself when you're doing this. So 1 minus 1 will give us 0. You can put the 0 or leave it blank, either or. 4 minus a negative would become a plus. 13 minus 3 would give us 10. So if you want to not put the 0, that's fine. If you want to put the 0, that's also fine. Solve for y, divide both sides by 5. And then take that, put it into one of the equations to find x. Again, doesn't matter which one as long as you do the math correctly. So let's say I choose the second one again. X minus our y, which is 2, equals 3. Solve for x. What would our final answer be? 5, 2. Even though we solve for x second, it's still xy no matter what. Questions on that one? Yes, Leah.
Is this 5y? Wouldn't it be plus 3y since there's a negative before the y?
I see why you asked that. But because we're subtracting everything, it's really 4 minus a negative. So we have to take that into account. So do you go ahead and close your laptop? Right. We're going to skip 3 and move on to 4. Everything lines up, so we don't have to worry about that. Which one has the same or similar coefficient? X. I said that because it doesn't matter if it's positive or negative. If you wanted to make them both be the same, you could multiply everything by the negative so that it changes, but it doesn't really matter. You still have to ask yourself, what would I do to these to make them cancel? Let's see. So if I were to subtract this, I'm going to double check in our calculator. 4 minus a negative 4. That wouldn't cancel. So that means I have to add. Now, you say subtract because technically that's what ends up happening, but we need to think about what we would be doing to both equations. We would be adding both equations together. General rule of thumb is if these two have different signs, you're going to be adding. If they have the same positive or negative, you're going to be subtracting. So if we add these together, 4 plus a negative 4, those are going to cancel. 9 plus 7 gives us 16, y. And then 5 plus 11 also gives us 16. Yeah, if you want. These type of problems are probably the trickiest because you want to subtract because eventually you're going to end up subtracting 4 minus 4. Yes, but think about it as a plus minus in this case. Because if I were to actually subtract 4 minus a negative, I'd actually be adding. So they're opposite. So solve for y. And then you can put y into either of the equations given to find x. So if I choose the first one, 4x plus 9 times 1 equals 5, would give us 4x plus 9 equals 5, and then solve for x. Subtract 9 on both sides, and divide both sides by 4. So then our final answer would be what? Negative 1, 1. Questions, concerns, confusion on that one? Five is the next one we're going to do for a couple reasons. One, these aren't lined up. So we either need to make the first one look like the second one or make the second one look like the first one. So do we want to change the first one or the second one? It doesn't matter. The first one, okay. So if we change the first one to look like the second one, the y needs to be on the same side. So we're going to subtract it over. And then I'm going to rewrite it. So negative x minus 3y equals 11. Now they look similar. And then do we have a common coefficient? The y's. What do we do to make those cancel each other out? So let's see. if I added these together, -3 plus a -3, that would do it. So I'd have to subtract -3 minus a -3. So yes, you're thinking because if they were added together, not actually added, but if I just like combine them, it would end up adding, yes. But again, think about what you're doing to both equations in general.
Why did you change it, like put the -3y and -x?
Because these aren't lined up right now. The equals aren't lined up. The y's and x's are lined up, yes, but the equals is not, so everything has to be lined up. So we changed the first equation so that they both lined up. Does that make sense? Okay. Do you see where this equals is?
Yeah.
You see where this equals is? They're not in the same spot.
Oh, so we have to switch it around.
Okay, so we're subtracting this and this. So 2x minus a -x would be plus. -3 minus a negative would end up being a plus, but those would cancel. And then 10 minus 11 would be a -1. What's going to happen when we divide? We're going to end up with a fraction. That's another reason why I wanted to do this one. This doesn't happen often, but sometimes you will get fractions. Usually if you get a fraction for x, your y is usually a fraction. Sometimes that's not the case. If you get a nice fraction, so like something you can easily put as a decimal, 0.5, 0.25, something that ends, you could change it to a decimal. If it's something that repeats, just leave it as a fraction. And then I'm going to do the rest of this work up here. I'm running out of space. So we have to put this in for one of our equations. If you wanted to do one of the two we already had or the change one, it doesn't matter. Any of those is fine. So let's say I put it in this, the change one. Negative times negative 1/3 minus 3y equals 11. And we would solve for y. This would become a positive 1/3. We would solve it like a regular equation. Subtract 1/3 to the other side. Do that in your calculator. Tell me what you get. Alpha y equals will give you your fraction. Yeah. Oh. What did we get for that? 11 minus 1/3. 32. It's a weird one. And then to get y by itself, normally we would divide, but then we'd end up dividing by another fraction. So to avoid that, I'm going to flip this and multiply by the reciprocal. Which would be the same thing as if you divided. What would your y value be? Do it in your calculator if you're not sure. 32 over 3 times negative 1/3. What would that be?
This is 32 over 3 times negative 1/3.
Mm-hmm.
I got negative 3.5.
Negative 30. Leave it as a fraction.
I have 32.
Yeah. Say what you said again, Franco.
Negative 3.5.
Sorry, the first part.
32 over 3.
Mm-hmm. Yeah, and then multiply it by negative 1/3. But yes, it should be negative 32 over 9. So then our final answer would be what?
Be negative 1/3 and 32 over 9.
Negative 32 over 9. Yep. So the answer doesn't look very nice, but that is our solution. If you ever got fractions or decimals, I would definitely use this time to, if it's a practice problem, use Desmos, double check, was I supposed to get a fraction? Or convert these so it's a y equals, put it in your calculator, and see where the intersection is.
Lisa, can we use this on this test or no?
That's what I said during practice. Right. Questions on that one? That was probably a harder one just because of the fractions, but the process is the same. There are 2 more that I want to do, and then any others that you guys want to do, and then we'll be done. Number 9. Everything's lined up correctly. Do we have a common coefficient for number 9? No. So in that case, we have to make one. It doesn't matter if you do for the x's or for the y's, it's really whichever you choose. I would say if you have something by itself like this x, probably do the x's because it'll be easier, but either or. So to make these have the same, we're going to multiply some number by either 1 or both so that they are the same. Because this has a coefficient of 1, if I were to multiply this by 2, then they'd be the same. But I have to multiply this entire thing by 2. So that the math rules are applied. What I do to one side, I do to the other. So that would change this equation completely to 2x plus 6y equals 12. Which is okay. We are allowed to change the equation as long as we follow the math rules. Now we have a common coefficient, our x's. How would we eliminate them? What operation would we use? Subtraction. So then subtract them both. 2x minus 2x, those would cancel. Negative 7 minus 6 would give us a negative 13y. Negative 1 minus 12 would also be negative 13. Divide everything by negative 13. And then you have 3 options of where you want this 1 to go. In the original or in the new, any of those, doesn't matter. So I'm going to put it into the first one. So that we have x plus 3 times 1 equals 6. Or x plus 3 equals 6. And then we can solve for x. So that x equals 3. And our final answer would be 3, 1. Do we have any questions, confusion, concerns about that one? So if the coefficients are not the same, you have to make them the same by finding some number that you could multiply by. If you started this problem and they were not the same and you started adding or subtracting, you would immediately get the wrong answer. So be aware of that. Alright, we're going to do one more and then any others you guys want. So there are 4 special case problems on here. 7, 8, 11, and 14. Of those 4, which one do you want to see right now? 7, 8, 11, and 14. You said 13 or 14? 13. Okay. 13 is a different one. 14 is what I said. 7, okay. But 13 when I ask for problems, we'll do that. For 7, they're all lined up. There should be an equal, so that was a typo. So they're lined up. We have common coefficients. Do we want to eliminate our x or our y? Doesn't matter. Y, okay. If you want to eliminate x, that's fine. So to eliminate y, these are both negative. To cancel them out, what would we do? Minus. That would happen to be the same if we were eliminating the x's. So our y's definitely are going to cancel. 3 minus 3, what happens there? They also cancel. So we end up with 0 on this side entirely. And negative 10 minus a negative 13 is really plus 13. Is this a true statement?
No.
No. So what type of solution would this be?
No solution.
Right. So you'll find out really quickly whether it's a no solution or infinitely many solution because both of your variables will disappear. You'll be left with either a number equals a different number or the same number equals the same number. Any questions, concerns, confusion about that? Okay. Look at the rest of the problems on this page and the next one. Find any problems you want to see, go over, have questions about, not sure where to start. Precious, I know you said 13. Josie, 14 on this page. Okay. 8. Any others? We have 8, 13, 14. 12. On this page. Alright, so let's start with 8. Everything's lined up. We have common coefficients for x and y. Which one do we want to eliminate? Or focus on, I should say. We're looking at 8. Okay. So to eliminate the x's, what operation would we do? Yes. Add the 2 equations together. That would also happen to be the same for our y's. So our x's would cancel. Y's would also cancel, leaving the 0. Negative 10 plus 10 gives us 0. Is this a true statement?
Yes.
So this would be what type of solution? Infinitely many solutions. Questions about that before we do 12? Every problem you probably want it to be no solution or infinitely many because there's like barely any work. But that's not how the window works. Alright, with 12, everything's lined up. Do we have a common coefficient? No. Do we want to eliminate x or y? Doesn't matter. Okay. I would say when you ask yourself that, look at which ones have the smaller numbers, just because you'll end up with a smaller number instead of bigger numbers, but it really doesn't matter. So if we wanted to eliminate our x's, we need to think about some number that they both could multiply to. What number could they both multiply to? 14. Sometimes the easiest way to figure that out is just to multiply them together. Sometimes that's a larger number than what it could be, but it doesn't matter. So for 14, I would need to multiply this by 2 and this by 7. If you wanted them both to be positive or both to be negative, you could change one of those to a -2 or a -7, either or. So then both equations are going to change. We have 14x plus 10y equals -26. And -14x minus 49y equals 182. Double check that. So then to eliminate our x's, we would do what? Add. So anytime they're different, add them. 14 plus a negative, those would cancel. 10 plus a negative 49 would be a -39. Y. And then -26 plus 182 will give us what? Then we can divide both sides by -39. I think that's -4. And then we can go back and find our x. Because we changed both equations, you have 4 options to put it back into. The original 2, or either of the 2 new ones, does not matter which one. Let me do this work over here. So let's say I put it back in the first one. 7x plus 5 times -4 equals -13. So 7x minus 20 equals -13. Add 20 to both sides. And divide. So then our final answer would be 1, -4. Questions on that one? For number 13, what would be my first step? Coefficients. Okay. Do we have those? No. So then what? Say that again. Okay. How would we do that? How would we find new common coefficients? Not yet.
Multiply the top one by 5 and the bottom one by 1.
Okay. We don't have to multiply the bottom by 1 because it would just stay the same. But if we're getting rid of our x's, yes, we could multiply it by 5. If we were getting rid of y's, we would multiply by 2 or negative 2. So let's do that. So we multiply the top by 5. Now what? Subtract both equations so that the x's eliminate. So we get negative 2 minus 5 will give us negative 7y. And And then negative 50 minus a negative 15 would be plus 15. And then divide both sides by negative 7. What would we do with that answer? Where? Either one. I would say do the first one because it would be less work, less solving. So x plus 5 equals negative 3. So then we have our final answer, negative 8, 5. For 14, do we want to eliminate our x's or our y's? Doesn't matter. Why? Okay. So that means we need a number that these both go into. So you could multiply them both. 24 would work, yes.
The top one by 3 and the bottom one by 2.
Yeah. So 12 would also work. As long as they go into both and you multiply the correct numbers, it doesn't matter. So we have 6x plus 12y equals 18, and 6x plus 12y equals 24. How would we eliminate our y's? But when we subtract, we also eliminate our x's. 18 minus 24, negative 6. What would our solution be? No solution. How do we feel about this overall in general? Good? Okay? Not good? Thank you to those that showed me. Thank you. Alright, I have a game for you guys. You can choose not to play, but I do have a prize also. It's bingo. For this, or because we don't have time, you wouldn't be solving the problem, so you could pull up Desmos or use your calculator, put them into Desmos, find the answer. And then the bingo boards have all the answers. And then at the end, whoever wins would get a prize. Or if you don't want to play bingo, you would need to continue practicing on this, on the notes, Khan Academy for this week, / the one that's due next week. Anyone want to play bingo? 1, 2, 3, 4, 5. Okay, if you change your mind, that's fine. So I'm going to have you 5 come up here. Anyone else can kind of spread out, move that way.